Hi, this is Mr. Mac with Sankofa Mathematics. This time around, I'm doing paper 1 of 2022, the AS level paper. Okay, right. Again, I always keep on reminding you to go through your instructions and your information, and you must also remember that you will be asked to give angles sometimes in radian mode and in degrees mode, and you need to make that back and forth change on your calculator. All right, so if your calculator is not set on radians, then you must make sure it's set on radians. If it needs to be set on degrees mode, then you do so. All right, and then if the answers are not exact and you are not told in the question that you are supposed to give the answer to this particular degree of accuracy, then you use as a default three significant figures. You should be very careful. There are a lot of times when they want the exact answer, which could be given in terms of radicals, which can be given in terms of pi, or whatever the case may be. But when you work with angles, if it's degrees, you give to one decimal place. If it's radians, you then give to three significant figures. Right, let's start with question 1. They say the equation of a curve is equal to y equals to minus x squared plus 3x plus 5. You need to express this in vertex form where a, b, and c are constants. Right, so this is then y equals to, I'm going to take out the minus first of all, and then I'm going to have x squared, then minus 3x. I'm just going to take it out from those two, right? From these two, taking out a negative. That is to identify the value of a, which in this particular case, I already identified the value of a is -1. And that also implies that once you sketch this curve, it's going to be a curve that has this particular, you know, format. All right, but um, what the vertex form also allows you, it allows you to find the turning point, which is going to be all the way up there, which is what you're going to see from this writing it in that form. Right, so then obviously the next step is to you take half of the value of 3, that is -3. And if I was to square this, I'm just going to keep this in bracket. If I was to multiply this out, I'm going to get x squared minus 3x, but there's going to be a plus 9 over 4 here. In there. So I'm going to then have to subtract 9 over 4, very importantly. And then obviously remember I had my plus 5 as they were originally. So let's distribute this negative over. It becomes negative. Then it's x minus 3 halves. And a negative times a negative makes that a positive 9 over 4. And it should be added with 5. Once you add those, you're going to have as an answer of y equals to minus x minus 3 halves all squared. And this business over here will give you 29 over 4. Which you can leave like this, or you can have x minus 3 halves all squared, and that is the same as 7 and 1/4. Okay, right, I wrote it in that form, but you can go ahead if you wish to. You can give the values of a, so you can say a equals to -1, then your b value equals to -3 over 2, and your c value equals to 7 and 1/4. Right. They say hence or otherwise write down the coordinates of the turning point of the graph. Now, it's very straightforward, as I was saying. The turning point, we just have to write them down from that equation. It's always opposite whatever the sign is. So opposite of that is going to be +3 over 2. And this value over here, the 7 and 1/4, right, that is your range, that's your y value. Okay, you can give it these decimals, whatever the case may be. Right, question 2, you need to solve the following equation. Now there's nothing really difficult in this. If you know how to solve quadratic equations, they always equal to 0. Okay, so that's 6. You're going to subtract 6 from both sides. This leaves you with 3x squared plus 5x minus 2 is equal to 0. Then this is obviously going to factorize. I'm going to have 3x outside the bracket. I'm going to have x plus 2, and then I'm going to have minus 1, and then you have x plus 2 as a common factor. Right, everything outside the bracket, you write in its own bracket, and then x plus 2 as a common bracket, you write it once. So from here, we're actually able to calculate. So it's going to be that either 3x minus 1 is equal to 0, or x plus 2 in itself is equal to 0. Then x is equal to 1/3 as an answer, or x is equal to -2 as an answer. Right, so this is part A of the question. So now, if you look at this question, this equation, you will see that they are actually kind of very similar. It's just that the only difference that you can see between that, where they have a y, there was a place of the x. So I'm just going to move that to that side. I'm going to rewrite this so that it can be in this type of format for us to realize something, because when you are told when you are told hence in a question, it means you're supposed to use whatever you have in part A to solve what is required in part B. I'm going to write this as 3y raised to the power of a half. Okay, but I'm going to square this. Okay, then I have plus 5y raised to the power of a half plus 4 equals to 6. Can you see that? Now, here's the thing. When you multiply out here, you're definitely going to get the same thing. So what you need to realize here, comparing the two equations, you should realize that x, what we calculated, is the same as y raised to the power of a half. But from A, we already have our two values of x. We know that x was equal to 1/3, or x was equal to -2. That's what we have from our answer up there. So we're just going to let y raised to the power half is equal to that. Y raised to the power half is equal to 1/3. Here, you obviously, or y raised to the power half is equal to -2. Right. You need to take square. You need to square both sides in order for you to get y alone. If you square on this side, you're going to have the quantity -2 all squared. So this value over here is +4, and this value over here is 1/9. Right, whenever there are questions that deal with roots, like y raised to the power of a half is square root, you need to do one thing. You need to check your answers to see if the left is equal to the right. And I'm going to use my 4 to see that. So I'm just going to grab a calculator, all right, and see if that's what I get. So I'm going to take my calculator and I'm going to use this equation. So I'm going to say 3 times 4 plus 5 times 4 raised to the power of a half, or otherwise you can also know that is also the same as a square root, power of a half. And if I add 4, am I going to get 6 as an answer? Clearly, this is not equal to 6, it's equal to 26. So you are therefore not going to consider this as a solution. What about 1/9? Now, let's see. Well, you go 1/9. So I'm just going to go back and put 1/9 where I have inputted 4 before, and see if this answer will equal to 6, because it's supposed to equal to the right hand side. Hit enter, you get 6. That tells me that 1/9 is the only solution. Okay, very important that you deal with that. So therefore y equals 1/9. This is the only solution. Take note of it. All right. Good, that takes me to question 3. Given that the coefficient of x cubed in this expansion is negative 1040, we need to find the value of x cubed. Right, so I'm going to write each of these because it's x cubed, so I'm going to write each of these up to about the third or the fourth term. So if I take 1 minus 3x raised to the power of 6, if I take this one, then the first term, remember, first term you get r is 0, right? R is 0. And I have got my 3 brackets to see what the first term will be. Then I'm going to look at my second term, 3 brackets. Then I'm going to look at what my third term will be, 3 brackets. Then I'm going to look at my fourth term. I'm going to have my 3 brackets. Okay. And I'm going to do exactly the same for the other one. So let me just follow in, right? You know that you always have ax, or is it a plus b? Okay. A plus b to the power n. Right, so my a values, according to that, is just going to be 1. So I'm just going to write 1 in there. My b value is, okay, sorry, I wrote it at the wrong place. First thing that I'm going to write here, this is going to be 6, 0, 6, 1, 6, 2, and 6, 3. Very important. Then this is my a value, which will be 1. Then here I'm going to have negative 3x, negative 3x, negative 3x, and negative 3x as my values of b. Another thing that I should, and you should know, is that this 0 should correspond here, this 1 should correspond here, this 2 should correspond here, this 3 should correspond here. And when you add them up, they should give you 4. So that becomes 3 plus 1, which is, they should give you 6 rather. So here, I'll have 3 plus 3, the wrong place, should be here. Adding these two should give you that number on top. 2 plus 4 will give you the 6, 1 plus 5 will give you the 6, and then 0 plus 6. So I can actually calculate my terms. And if I do so, this one here is going to be 1 on its own. This one here is going to be negative 18x. And this one here, if I calculate this one here, I'll get 135x squared. And this one over here is going to be negative 540 x cubed. I needed to get a term in x cubed. That's why I'm ending. So just to show you how I get term 4 for you, for example, I say 6, choose 3, right, times 1, because 1 cube is just 1. And then I'm going to multiply that, not by that x, but times negative 3, and it should be raised to the power of 3, right? If I hit enter, you see I get my 540, negative 540, but I also know at the same time that x should be cubed. Here x should be squared, here is x to the power 1, and anything to the raised to the power of 0 is equal to 1. Okay, so I have now the terms for the first 4 terms for that. I'm going to do the same for this one, which is the 1 plus ax, and it was supposed to be raised to the power of 4. So I'm going to do the same with term 1. I'm going to have 3 brackets. Term 2, I'm going to have my 3 brackets. Okay. Term 3, same. I'm going to have my 3 brackets. Okay. And then term 4, I'm going to have my 3 brackets like so. All right. So I still have enough space to complete the other stuff. Right. Let me just write in. Of course, I know that as before, this is going to be now 4, choose 0, 4, choose 1, 4, choose 2, and 4, choose 3. These are all constants that you can calculate. My a value is going to be 1. In this case, it's also 1. So I'm just going to go ahead and put 1. My b value is ax from the formula. And then also remember, I said that what you have over here, this is going to be 0. This one corresponds with 1. This one will be 2, and this one will be 3. And together you need to get a 4. So this is going to be 4, because 4 plus 0 will give you that one on top. This one has to be a 3. This one has to be a 2, and this one has to be a 1. Now we can actually calculate what those terms are. This is going to be 1. This is going to be 4ax. And if you calculate this one, this is going to be 6a squared x squared. And this one is going to be 4a cubed x cubed. So those are the terms, 4 terms for each one of them. Now, what is it that I'm looking at? I'm looking at the terms that contain the x cubed. There is a shorter way to do it, but I think it will be, easy. If you could also calculate which term is going to be giving you the x cubed, or r equals to 3, for you to be able to know that that has to be the 4th term. All right. So we'll be looking at that as well. So for now, I'm going to stick with that. So what I have over here, I can see that the term in x cubed is this one over here, which is minus 540. And the one here is going to be 4a cubed. These are the 2 terms that I am going to let to equate to this number over here, which is minus 1040. So at the end of the day, I have negative 540 plus 4a cubed is equal to negative 1040. That is what I have. So I'm going to have 4a cubed is equal to negative 1040 plus 540. Okay. If you add these two, you're going to have 4a cubed is equal to negative 500. Then a cubed is going to be negative 125. And to find the value of a, you say that the value of a is going to be the cube root of negative 125, which is possible. It's only the square root, which in this case is negative 5. Therefore, a equals to negative 5. Right. As I said, you can have various ways to calculate that. There is no way for you to see that this is going to be the 4th term, that r in your formula is going to be 3. But you can definitely play around and you can see what that is. All right, because you have got a scenario where they say the term in x cubed, right? And if that is the case, perhaps before I start with this question, perhaps we can see if we can do that. So let me see if I can just add a page, append it, so we can maybe look at that scenario, say if someone was to do that. So you do know the formula, the r plus 1 term formula, which is obviously based from the idea of a. So if you have a plus b to the n scenario, then the general formula will be n choose that r. Then you have your a, which is going to be n minus r over here. Then you have your b to the r. This is the general formula, right? So if we were to do that for this one, so let's do this for this one. 1 plus, no, it was minus rather, minus 3x raised to the power of 6. And the other one that we also have to consider was 1 plus, so it's 1 plus, what is it, ax raised to the power of 4. Then I know that they were talking about the terms in x cubed, given that the coefficient of x cubed in the expansion. So in x cubed, so I will be saying, okay, wait a minute, I'm looking for things in x cubed. You can have um, a 6 taking the red one over here. I will have 6 choose r, which I don't know, but I know my a is 1 from here, so this is going to be 6 minus r, and I know by b, which is negative x. Now here's the thing, r is going to be a certain value. Okay, so that's what I have. I'm just going to look at the term that have got the x cube. I'm not interested in the 6 choose r because this is a constant. I'm also not interested in this. This is a constant. I'm also not interested in this. This is a constant. What I'm interested is in this one. Why? I'm going to take this one and let that one equal to x raised to the power of 3. So I'll be saying x raised to the power of r should equal to x raised to the power of 3. Therefore, r is equal to 3. Does that make sense? Because you are now working with the coefficient of x cubed. Now that I know what r is, you can just go back in there and you can find the coefficient. The coefficient will be the one without the x cubed. So if you find the coefficient now, you will be saying, since you now know what r is, you will be saying, okay, 6 choose 3 now. Then you have 1, 6 minus 3, and then you have negative 3 to that power. Right, so this is going to give me the coefficient. And if you now play around with that and see what you get, so it's obviously going to be a scenario where you're going to have this answer, which is already over here. Then you have the minus 540. And that is the minus 540 that we have over here. And you will be doing similarly the same thing for the other one. The other one is this one in blue. All right. So I can append another page and do that one in blue so that you can see you can also take that route, so to speak, for you to do so. Right. So I can say, okay, so let me take a snapshot of this. Hopefully the software is not acting up because it's one of those things. Right. So if I have to find also working with that and using my general formula, then if I was to use my general formula, I'll say, okay, this then implies that if I have, so you know the general formula, so I'm going to have 4 choose R, so you don't know what R is, okay, so you're going to say 4 choose R, then A is 1, this is 4 minus R, and then B is AX to the R. But we are looking for the coefficient of the term x cubed. So let me just take out the constants. This will all be constants. This will all be constants. And a will be a constant and x is going to be that. So you are going to see from here x to the power r. Don't have to do much. You can actually determine that x to the power r is equal to x to the power 3. Therefore, r is equal to 3. Now that we know what r is, we're going to put it back into the constants, the one that contain only the constants, which is this ones, only the constants, in order for me to find that coefficient. So that is going to be 4. Now you're going to say, okay, now that is going to be 4 choose 3, which is a number that exists. Then 1 raised to 4 minus 3, 1 raised to anything is 1. Then you have a raised to the power of 3. If you do this, you are going to get 4 choose r, which is 4. So this answer is 4a cubed. Now that you know what they are, then you'll be taking this to coefficients, and then you will let them equal to that answer as I was doing in that case, and you'll still be able to solve. Okay. Right, so then you can go ahead and do so. All right, so let's just go then and do question 4. They say the quadratic equation has unequal roots. whenever you are told to find the set of possible values, you know that you are dealing um, with an inequality. And we also know the determinant should be greater than 0 because this is the only case where the roots are unequal. So you just have to have your determinant, which you know as b squared minus 4ac, identifying your b here in that equation, that is negative 5, squaring that, minus 4. Identifying your a there, that is 2, and identifying your c, it's 8k squared. Okay. What is that giving us? This is going to give us 25 minus 64, that's 8 times 8, k squared. This is what this is. Right, because you have a scenario where the leading term has a negative, this is how this particular function would look, and it's going to be below the x-axis. So whatever values you're going to find, you're going to have a value that either goes in either one of those directions. So I'm going to let this equal to 0 in order for me to find those critical values. So for me to calculate the critical values, all right, I know I'm supposed to. So this is my A, this is my B. Whatever one answer will be, X will be less than A, and another one, X will be greater than B. But for me to find my A and B, I'm going to let this 25 minus 64 k squared equals to 0. And then I will go back and put my inequalities as they are supposed to be. Okay. It's not below, but it's rather on top, is it? Okay. So when you solve this, my inequality, so my yellow here, obviously I am just slightly out with my reasoning. I'm slightly out of my reasoning. So because my inequality is, if I was just a little bit, it's greater than, okay, so it must be above. The inequality is greater than, all right, so no problem. Let's just correct that scenario. So this is why I always have to refer back to, when I talk about my critical values, A and B, where is the function above the x-axis? So I'm going to be getting values that are here. So it's like an AND inequality. So whatever I'm going to calculate, x would be between A and between B. So my answer should take this form at the very end. That's what I was now looking at. All right, so definitely solving obviously here, you're gonna get 5 minus 8k. That's like the difference of two squares, and the other bracket will be the conjugate of the other one, which is 5 plus 8k equals to 0. You will have one answer will be of k will be 5 over 8, or the other one will just be the opposite, which is negative 5 over 8. But remember, our answer is supposed to be an inequality, possible values. So it's going to be that form where the k is in the middle, okay, flanked by the bigger value here, which is 5 over 8, and the smaller value here, which is that. Right, and that is the solution as required. Okay, so it's very important that you also have that understanding of the graph or the sketch, how it's going to appear and what is the determinant going to be, or the discriminant. Right, let's look at question 5. Question 5, just have to keep on saving. Question 5 says, in an arithmetic progression, that is an AP. So this is an AP. Then they say the third term. So the formula for an AP is T sub n is equal to A plus n minus 1 D. So when they say the third term is A plus 3 minus 1 D is equal to 14. So my equation is A plus 2D. How many D's do I want to write now? Is equal to 14. So this could be considered to be my one equation. Then they are also saying the sum of the first 8 terms. Now this S sub n formula of um, an AP is n over 2, and then you have 2a plus n minus 1 times d. So we need to be able to see what we can substitute. They are telling us what the sum of the first 8 terms will be. So the sum of the first 8 terms will be 8 over 2, then 2a plus 8 minus 1 times d. This is obviously equal to 148. So I'm just going to clean this formula to create a second equation. And if I do so, I'm going to have 4 in bracket, it's 2a plus, is it 7d is equal to 148. I can still clean this up by dividing both sides by 4. And at the end of the day, I have 2a plus 7d, and 4 goes into there 37 times. And this is the other formula, right, that I'm going to now solve. Right, maybe this formula can also be written. I can also write this formula here. Oopsie daisy. This formula can also be written. This formula can be written by making A the subject of the formula. You can write this as A is equal to 14 take away 2D. Because I want to use the method of substitution, I'm going to substitute here for A into this formula. And that will be allowing me to calculate my D, and subsequently I'll use the blue formula again to find my A value. So substituting that into, that is going to be 2 in brackets, you have got 14 minus 2D plus 7D equals to 37. Okay. If you do so, multiplying out, you get 28 minus 4D plus 7D is equal to 37. This is 3D is equal to 37 take away 28, that is 9. Therefore, D equals to 3. So if D is equal to 3, I can use this formula to find my value of A. That formula was originally A plus, or A equals to 14 minus 2. My D value is now this. 14 minus 6 is 8. Therefore, A equals to 8 and D equals to 3. And these are my values that they are looking for, the first term as well as the common difference. Okay, that's what they are looking for. And this is the solution to this particular question. Okay, that does it for question 4, 5. Just let you take it, read it in. There is a B part to the question, however. So let's see what a B part is. Well, it also has to deal with sequences, but it's unrelated to that one. So they are saying you must evaluate. Now, there are calculators that can do this, but of course not this, the infinity one. So you have a problem there. So you have to find the sum to infinity. The first thing is, this is a GP, because sum to infinity only work for GP. So we need to be able to, because the formula for sum to infinity is A over 1 minus R. We need to know what is the first term and what is our R value. Okay, what is the first term and what is our R value? So the first term clearly will be 5 over 4. Then you have 3, 1 minus, obviously that 3 that you have over there, here in the index. This is going to give you, if you work it out, 5 over 36. Let's just do the second term as well. So that's 5 over 4. Then it's 3, 1. The next one is going to be 4 if you continue. And this is going to give you 5 over 108. I don't necessarily have to do the third term, okay, because I know this is a GP. So I can actually calculate my R. My R is the same as taking term 2 divided by term 1. So that is going to be term 2 to find my R value. So I'll say R equals to 5 over 108 divided by 5 over 36. So if you do so, you will see that your R is 1 over 3. Okay, let's just confirm. It will be 5 over 108, and I'm going to divide that by 5 over 36. And my R is 1 over 3. What? We also know that my first term is 5 over 36. So this sum to infinity can now be completed. So the sum to infinity, all right, that infinity symbol, is going to be A, which is 5 over 36, divide by 1 minus 1 over 3. So it's just a matter of then punching it in to the formula and see what the outcome would be. And you would see that you get 5 over 24 as the outcome. Okay, right. So you had to be able to first identify what is your A value, okay? You now also need to know that you are dealing with sum to infinity, as R works for sum to infinity only when R is a fraction that is between 1 and negative 1. And in this particular case, we did arrive that R is equal to a third, and if R is a fraction, like so, then if you add these, they become smaller and smaller and smaller, and then they tend to a number, and that number is 5/24. Right. Then we have question 6. The function is defined, f of x is defined as f such that x is mapped onto the natural log of x minus 2. Knowing a few things of the natural log, you should know that the natural log, this part, should be greater than 0, and therefore x should be greater than 2, and therefore k is then equal to 2. Right, they want you to find the inverse of that, so I'm just going to write that function as y equals to the natural log of x minus 2. I'm going to switch the variables around because I want to make y the subject of formula. It's just a method. The natural log is nothing but, remember the natural log is nothing. Natural log is nothing but, so if I have the natural log of, let's say, y minus 2, this is actually the same as log base e of y minus 2. So these things are exactly the same. So why is that? Why does that matter? So maybe I should just remove this ln notation and replace it. I hope this is not going to give me a problem again with log base e, so that I can change this from log form to exponential form. That is going to be e raised to the power of x is now equal to y minus 2. Okay, then y is going to be e raised to the power of x plus 2. But we are not looking for y, we are looking for the inverse. Then the inverse is going to be e to the power x plus 2. And surely you now have the understanding that this is the answer. Okay, you don't leave your answer in terms of y. They want you to sketch the graphs of the inverse as well as the exponential graph on the same diagram. I'm going to just take the original graph of f of x, and I'm just going to write in this form, not in the mapping form, f of x, which was equal to the natural log of, is it x minus 2. Can even write it in y equals 2. Okay. The reason I want to do this is I know that x should be greater than 2. I know that x should be greater than 2. Therefore, my graph will have an asymptote, right? It will get closer, but it cannot pass It will have an asymptote at x equals to 2. So I'm going to draw a dotted line of x equals to 2. And if I do a dotted line of x equals to 2, I'm also then going to have a dotted line in the inverse function, okay, of y equals to 2. But before I write that information down, I want to know also, where does this graph that I'm going to draw, where will it intersect with the x-axis? The intersect of the x-axis when y equals to 0. So the natural log of x minus 2 is equal to 0. Then x minus 2 is equal to e raised to the 0. Remember, the natural log is the log base e. Then x minus 2 is equal to 1, anything raised to the power of 0. So x will equal to 3. So it will intersect at x equals to 3. Now, the opposite is going to be the case. The inverse of this graph, right? This is f of x. So the inverse graph, this inverse graph, it will have an asymptote in y equals to 2. So I'm going to draw a dotted line there as well. And it will cut the y-axis at the place y equals to 3. These are very important things that you need to take into consideration. So I can actually go ahead and I can draw my graphs, see what they will be. So bringing in my axes. So bringing in my axis, I'm going to probably have my x-axis over here, my y-axis rather, and I'm going to have my, maybe a little bit down here, okay, here, I'm going to have this as my x-axis, right. Just take this off and just write it as y equals to 3 over here. So y equals to 2. This is where the asymptote will be, and then we will cut the y-axis at x, or cut it. But I think you have the idea. All right. So let me do my x-axis. Okay, because I'm running out of space. I said there's going to be an asymptote. The asymptote here is going to be the line x equals to 2, but I'm just going to draw it until so. Don't really want to continue too much with that. This one is going to have an asymptote at line y equals to 2, so I'm just going to end slightly there. Right, if I draw the graph is going to be, the function is going to be something like so. This one is my f of x, and we know that we said it's going to cut here. And this is obviously x equals to 2. This is y going to be 2. And if you draw the inverse graph, make that blue, the inverse graph is going to be something slightly like so. And this is going to be at 3. And this blue one is the inverse. Technically, those are the only things you needed to do. Perhaps we can also go ahead and put the origin here of 0. So there's a reason why I didn't continue with my dotted line, but you could have continued with that if you want to. If you draw the line y equals to x, the dotted line y equals to x, it's going to be a line that is like a reflection of this function and its inverse. Basically, that's it. So you had to find a few information for you before you could actually draw this graph. Okay, that brings me to question 7. It says a curve has an equation. The equation of the curve is y equals to x to the power 4 minus 5x minus 3. And then it has a line which, and a line has an equation, a different line has an equation, minus 9x plus a. That minus 9 is the gradient. The line is a tangent to it, the curve at point P. That means the gradient of the curve, okay, the gradient of the curve, dy dx, is equal to the gradient of the line, which is minus 9. So let's find the gradient of the curve. So dy dx is going to be 4x cubed, always take 1, minus 5. And I am going to say let that equal to negative 9. This is going to give me the value of x. Okay, right. So this is 4x cubed is equal to negative 9 plus 5. 4x cubed is equal to negative 4. Okay. In turn, this is going to be that x cubed is equal to negative 1. And that is x is going to be negative 1. So that is my answer. Okay. The cube root of negative 1 for what the value of x is. They say we are supposed to find the coordinates of point P. Now, point P, if I know the x value, I can calculate the y value. I can take this x value and I can substitute it back into the equation of the curve or the equation of the line. But I'm not going to do so in the equation of the line because there's another unknown variable. So I'm going to substitute into the equation of the curve to find my y corresponding value. So when x equals to negative 1, then y is going to be negative 1 to the power 4 minus 5 times negative 1. Okay, this is now I'm substituting into the curve. Y will give me a value of 3. Therefore, the p value that they are now looking for, the coordinates of p, therefore the coordinates of p is negative 1, 3. Okay. Remember the equation of my line was y equals to negative 9x plus a. They're also asking us to find the value of a. Why am I going to substitute the point negative 1, 3 into the line? Because the line is a tangent at the curve. At that point, they are exactly equal. So substituting the value of x and y into this line, y being 3 and x being negative 1, will allow me to find the value of a. Okay, let's just 3 equals to positive 9 plus a. The a value will be 3 minus 9, which is negative 6. So I do have my answers then. Okay, they said find p. We did. P was negative 1, 3. And then they also said calculate a, which is negative 6. And this, you always have to go and read your stem carefully so you can answer the questions that follow. Okay. Right, so those are my solutions towards this question here. Right, that takes me to question 8. We have a flexible piece of wire and it is 60 centimeters long, which means that is the perimeter of that. Okay, so this is also going to be r centimeters, this distance here. AB is going to be, it's an arc length. And I know, and I hope that you know how to calculate the arc length. The arc length is given to us. How to find the arc of the formula is somewhere. Okay, so the arc length, the formula is always given. So from my knowledge of, I know that it's theta over 360 degrees, if it was degrees, times the circumference, which is 2 pi r. But we know that we are not dealing with degrees. We know that 360 is the same as 2 pi. So that's the same as 2 pi. Then obviously the pi's, they cancel. The 2 pi's cancel, leaving me with the arc length, which is r theta. R theta. So this arc length is r theta. That's what I have. Right. Then they say we have to express theta in terms of r and show that we get the area for this. So first thing is we have the perimeter and we need to use the perimeter formula. All right, it's not really a formula per se, but you just need to know what is it that you are doing. So I have to sort of add the distances around this. So it's going to be r plus r theta, that is going to equal to 60. That's what I'm going to do there to find the perimeter. So the perimeter, which is going to be r plus r theta, is equal to 60. This is 2r plus r theta is equal to 60. They say we have to express theta in terms of r. So I'm going to make theta the subject of the formula over here. Okay. So to do so, first I'm going to say theta r is going to be equal to 60 minus 2r. Then theta on its own is going to be 60 minus 2r divided by r. So this is theta. Right, what do you know about the area? So if I have to calculate, they ask me to calculate the area of a sector. The area of a sector, this shaded part that I'm doing here, it's given by the formula. It's given by the formula, and it is in your formula sheet, a half, very important that you should not forget it, theta r squared. That's the formula. So this gives you the area of the sector. So using that, the area of the sector, and I said it's a half theta r squared, but we know what theta is, so we're just going to substitute our theta value in there, right? So it is a half, and theta is 60 minus 2r over r, and we're going to multiply this with r squared. Now there's a lot that you can do over here before you find half. You can actually say that this one of this r is going to cancel, leaving you with a scenario of a half 60 or half r, and then you have 60 minus 2r, that is this r times here. Now you're going to find half of everything. Okay, and then always look at how your answer should be. A half r of 60, well, that is just nothing but 30r. Half of that gives you, they do cancel, is it? A half of 2r. So when you do that, the 2's cancel, r times r is going to give you r squared. Just quickly charge this. Okay, so at the end of the day, if you multiply half over, you're going to get minus r squared, which is the area. And this was what we also were supposed to prove. It was given to us, we were just supposed to prove that. Okay, and let's compare. It's 30r minus r squared. There we go. Now, when they say given that r can vary, find a stationary value, this happens where dA dr is equal to 0. So we need to find the derivative of that, okay? So just quickly write what it is. It's 30r minus r squared. Then we also have to determine the nature. We also have to do two things. It's very important that you understand. There's a conjunction and determine the nature. To determine something's nature, we will be taking the second derivative of that and see what that value is. Okay, right. So let's first find the first derivative and equal to 0 for us to find what the stationary value is. Okay, so if you do dA dr is going to be 30 minus 2r. Okay, if you say 30 minus 2r equals to 0, this gives you negative 2r equals to negative 30. This would be that r is equal to 15. Right. What is the area? Because find the stationary value of A. So what is the area? Is it the area is going to be 30. We know what our r is now. So our r is 15. So the area is given to us as 225, I believe. if you punch that in. Okay, so that's the area. Now we do know the first derivative. We want to find the second derivative so that we can determine the nature of the stationary point. So the second derivative, if I do the second derivative, that is the second derivative, this is just notation, will be -2. And if you, that is obviously from here, if that is the case, what you realize that since the second derivative is less than 0, this has to be that the nature of this is going to be a maximum point. Very important that you two realize that. Okay, so we have answered the questions that we need to. We have our R, we have our area. Okay, they say given that R can verify the stationary value of A, and determine its nature. Stationary value of A means you need to find that area. What is that area going to be? So we did calculate that. So we know what the stationary value of A is. When R is equal to 15, what is that value of A? That is, you are actually asked to find the area. That's what you are looking for. We determine the area, and then we determine the second derivative. And if that is the case, we then said, yeah, its nature is going to be a maximum if the second derivative is a value that is negative or less than 0. Question 9, sorry. They say show that the equation 3 tan x is equal to -2 cos x can be written in this form. So what do we know? As far as tangent is concerned, we know that tangent can be written as sine x over cos x. That's what we know. And this is equal to -2 cos x. Right. There are many ways that you can do this. Okay. You can obviously say this is nothing but 3 sine x is going to be -2 cos square x. What I do is I'm multiplying both sides by cos x, and if I do that, the cos x cancel, and I also multiply this side by cos x, and cos x times cos x is cos square x. Now my equations are given in terms of sine, so it doesn't hurt for you to know that cos square x is exactly identical to 1 minus sine square x. This you know from your Pythagorean square identity. Sine square x plus cos square x is equal to 1. So excuse me, where I have cos square x, I'm going to replace that by 1 minus sine square x. Multiplying out, this is -2 plus 2 sine square x, and that equals to 3 sine x. And we're just going to rewrite this in that form by moving this 3 sine x to the right or subtracting it. Therefore, I'm going to have 2 sine square x minus 3 sine x minus 2, all of that equal to 0, which is what we proved from what we had over there. Okay, so we established that. Right, so very important that you take note of a few things and how they can be written. Okay, it helps you whenever you are sitting with those type of scenarios. Now they are asking us to solve this equation, and we are supposed to solve this equation, and it's in radians from 0 to 2 pi radians. Now we know what that equation is. That equation is over there, so that equation also will be factorizing. So I'm just going to go to 2 sine x, and then you're going to have sine x minus 2 in one bracket, and then you're going to have plus 1, and then you have the same sine x minus 2, and that equals to 0. Some people will say let sine x equals to k, and then they work in terms of k. By now, I expect that you should be able to do this without having problems. 2 sine x plus 1, and then you have sine x minus 2 is equal to 0. And when you now solve the first bracket, you have got, this is going to be eventually sine x is equal to -1/2, or sine x is equal to 2. And you should know from the sine graph that the sine curve oscillates between 1 and -1. So this one, you are going to reject this. Now we know that we have our negative where sine is negative. So first of all, sine is negative in the first quadrant. So if, according to your CAS diagram, sine is negative in the third quadrant as well as in the fourth quadrant. Okay, so what we are going to look for is we are going to look for an angle theta, or I'm going to call that a basic angle. All right, so such that once we have determined what that angle is, we are going to say, because this is 0, this is pi over 2, 90 degrees, this is pi, then this is 3 pi over 2, and then you go back to 2 pi. Okay, so we are looking at one possibility, which is this angle here. And to find that angle is going to be nothing but pi plus whatever that reference angle is. Then if you have to find the other angle, and you look at, okay, what if I go all the way from here, all the way around, up to there, you realize, oh, it's actually started it wrongly. It's supposed to start from here. So maybe I do it in the inside, all the way up to here. So to find that angle will be 2 pi minus my theta. So I'm going to call my theta the basic angle. So the basic angle I'm going to look for is this. So I'm looking like for the acute angle. And from your special triangles, you should know, that this theta angle is going to be nothing but pi over 6, or 30 degrees. Okay, so in the third quadrant, my solution is going to be that x is going to be pi plus pi over 6, which eventually will give me 7 pi over 6 radians. You can obviously write that as a decimal if you want to, and give 3 significant figures. And in my fourth quadrant, x is going to be 2 pi, as I indicated, minus pi over 6, and that is 12 pi minus 1 pi, that's 11 pi over 6. Okay, so these would be the two solutions for x. You can say, therefore, x is equal to 7 over 6 pi, or 11 over 6 pi. Okay, you can also give the answers, again, as I said, as decimals, and you can go ahead and do so. I'm just going to leave them in terms of pi. Okay, not that the question said that, but it's just better. That brings me to question 10. Question 10, you have a diagram, shows the curve of y equals to a sine bx. So we can see that it's from 0 to 360 degrees. We need to find the value of a. And it's very clear that this curve is oscillating between 3 and -1. And if that is the case, you know, the amplitude, which is what the a value really represents, the amplitude is always your maximum minus your minimum, okay? And it's an absolute value, and you'll be dividing that answer by 2, okay, for you to know. So in this particular case, our a will be the maximum, which is 3, looking at the curve, minus the minimum, which is -1. And whatever that answer is, we are going to divide that answer by 2, okay? And if you punch this in, this will tell you that a is equal to the absolute value of 4, which is 4 divided by 2, which is 2. Right. Then what is b saying? B is your period. And if you look at the sine graph repeats itself after every 360 degrees. And typically the sine graph will go something like so. So that's one period. Can you see that? Because it goes, and then the second one, as you can see, because it still continues, so that's going to be the second one, goes again all the way up to 240. Can you see that? So how many of these sort of cycles will I have? Well, you can see that I will have 3 of them. That's going to be the third one. Okay. So the answer then for B would be that B is equal to 3. Okay. Or you can say that since you know that the sine graph repeats itself after every 360 degrees, then you say B would be 360 degrees divided by 120, which is equal to 3, because they have like 3 of those cycles in there. What else? The value of C. The C is normally the sine graph will start at 1. So this graph has been shifted upwards by 1 unit. Okay, so this way it intersects, that is already your answer. So C is equal to 1. So therefore, you can actually now give your answers. A is equal to 2, B is equal to 3, and C is equal to 1. Very important that you also answer the questions nicely at the end. Now, I already spoke about the period of the curve. The period of the curve, in this particular case, it's 120 degrees. Okay, since it's in degrees, I'll just leave it in degrees, but you can go ahead and give that in radian mode if you wish to do so. The curve is now reflected in the x-axis. So when you reflect a function in the x-axis, so let me just write what that curve is now. That curve is it f of x, or it's y. So that curve is y. So the equation of the curve is now y. I can actually complete it. 2 sine b is 3x, right? Can put it in brackets if I wish, plus 1. When you reflect this, then the whole of this curve will be multiplied by -1. Multiply the whole of this function by -1. So that means the reflection in the x-axis implies that the whole of this function should be multiplied by -1. So what is the new equation? Therefore, the new equation, so from here, I'm just going to write it here because of space. The new equation will be, I'm just going to say new equation will be minus 2 sine 3x minus 1. That is the new equation. And you distribute everything in there. Good. Right, we now come to question 11. It says the diagram shows a trapezium and the trapezium OPQR, in which OP is parallel to RQ. The position vectors of P and Q are given relative to your origin. The magnitude of RQ is twice the magnitude of OP. So maybe I'm going to start off writing that down somewhere here. I know now that RQ, whatever RQ is, will be twice OP. Okay, and I have OP. So this is 2, OP is 3, -2, -1. So this is going to be 6, -4, -2. So this is my RQ. No problem. Why is that necessary? They are asking me to find the position vector of R. Okay, show that we get that. So we are looking from O to R. So to go from O to R, you have to go and consider Q, OQ. So I'm just going to write, maybe I'm going to make it the dotted line so you can understand what is it. I'm going to go here. So highlighting it, this is what I'm looking, OQ, right? OQ, and then QR. That is how I will find that. Right, so what is OQ? If you look at OQ, we were given OQ is here. So let me just write OR nicely so you can see what I mean. For me to go from O to R, I'm going to go O, okay, that's supposed to be O, yeah, OQ, right, as I showed in green, plus QR, okay, okay. Now what is OQ? It's given to me here. OQ is 5, 1, and 2. Now what is this value? Now QR, I have calculated here RQ. So from this, if I have to find QR, it's just going to be opposite that. So RQ is equal to negative QR. Very important that you need to understand that. So my QR, therefore, RQ, this, if I switch, multiply that by negative. So RQ would be, this is going to be a negative 6 now. This one is going to be a positive 4, and this one will be a positive 2, right? So that is what I'm going to bring. Okay. So that is going to be my QR. So I'm going to add 6, negative 6, 4, and 2. So add negative 6, 4, and 2. What does that give me? 5 plus negative 6, that's negative 1. 1 plus 4, that is 5. 2 plus 2, that is 4. And surely we have proven what we needed to prove over here. Okay, so we did prove our OR. Right, let's continue to the next question. Use the scalar product to find the angle POR. Now, what I always say, you should always look at this scenario where you create yourself a angle, the angle that we are looking for. O is here, so O to R and okay, O to P. Always, you always have to go away or towards O. Okay, so we know what OR is. We also know what OP is. Let's just write them down as we have them. OR is what we were given or we proved, negative 154. So I'm going to write that one down here. That is negative 154. This is OR. OP is given to us. OP is given to us in the question. OP is 3, negative 2, negative 1. 3, negative 2, negative 1. So I'm going to write that down here as well. 3, negative 2, negative 1. Just make sure about that. We have got 3, negative 2, negative 1. Right. Why is that important? Okay. In order for you to calculate the angle here that is being created, this angle, let's say we call it theta for now. The formula is cos of theta will be whatever is OR dotted with OP. So we have to find the dot product of that. And this is going to be divided by the magnitude of OR times the magnitude of OP, right? Which we'll be able to do. So let's calculate their magnitudes first. And I'm going to do the magnitudes here. And it's basically just using Pythagoras. The magnitude of OR is equal to 1 squared. I am not going to, okay, but let's rather do that. Plus 5 squared plus 4 squared. Everything square root. This is equal to, this is going to equal to the square root of 14. Okay? Then let's find the magnitude of OP. The magnitude of OP is 3 squared plus negative 2 squared plus negative 1 squared square root, and this gives me, if you calculate it, the square root of 42. Now let's find the dot product. Okay, so let's now do OR dotted with OP. Right. See if I have space. Okay. OR, we know that OR was -154. We're going to dot it with OP. OP is 3, -2, and -1. Okay, I'm going to find what that is. All right. So just make sure that you have them from there. That's why we keep on writing them down. Right. You're going to multiply the corresponding components and add. So it's -1 times 3. Add 5 times -2. Add 4 times -1. And if you do all of that, you're going to get that. Let's see what we're getting. Let's calculate. Okay. -1 times 3, that's -3. Plus 5 times -2, that's -10. Plus 4 times -1, that is -4. Okay, so it looks like I'm going to get a negative answer. It's -17. If the dot product is negative, the angle is obtuse. Remember that. Okay. So conversely, if the dot product is a positive value, the angle is acute. If the dot product is 0, the angle will be 90 degrees. So now we can substitute everything into our formula. So to find my angle, what was the letter? Angle POR. Angle POR. Angle POR. It's the inverse cosine of the dot product, -17, over, what was my magnitudes? Square root of 14 and square root of 42. Okay, that bracket looks suspiciously okay. Good. Let's punch this into our calculator and see what we get. Calculator should be in degrees mode because we are given this in degrees. So I'm just going to change that to degrees. So I'm looking for the inverse cosine. Have my fraction, so I know that the dot product is -17. And as I was saying, we are going to have an obtuse angle. Okay, cosine is negative in the second quadrant. Then times the square root of 42. Okay, and I'm going to go out and have all of that and hit equal to. Right, so let me just capture that, paste my answer. I have the fortunate to be able to do so. You just have to write from your calculator. Therefore, the angle to 1 decimal place, they didn't specify in the question, but from your instructions right from the beginning as I was introducing this, I said angles in degrees should always be given in to 1 decimal place. So 134.5 degrees to 1 decimal place. Okay, so this solution that we're looking for. Okay, right. So hopefully you also took note of this little sentence that I have put here. Very important that you understand that if your dot product is negative, your expectation, because they didn't tell you here, right? And this diagram is not to scale, so if it has to be to scale, it's going to open up a little bit more, all right? But whenever you calculate the angle, always do this and let your vectors move away from your angle, which is in the middle, or let them both go towards the angle. That's what you do, okay? And then from there, you continue and work like normal. And I do believe that the formula is also given to you in the formula sheet, all right? They might be given to you as the vector A dotted with vector B over the modulus of vector A multiplied by the modulus of vector B. And you just have to now make sure that you have the correct vectors, and then you work the magnitudes and you work the dot product and you substitute into the formula in order for you to calculate what is missing. That brings me to question 12. Now, this is still 3 more questions to go. The diagram shows a container. The container is in the shape of an inverted upside down cone with a circular base, upright and horizontal. And then they are saying the height of the container is 30 centimeters, as you can see, and the base radius is 18 centimeters, as you can see. Now, what I'm also seeing here is they say water is flowing into the container when the height of the water is h, as you can see, a little nicely in blue. The surface of the water has a radius of r, and the volume of that is going to be v. Okay. They want us to express r in terms of h, which means we need to find our h or r first, and then we need to be able to see what is the volume of the water that is in there. Now, I don't know if you can see, but you should be able to see something very interesting, and I'm going to draw it here. But let's not use dotted lines. So I'm seeing a triangle, like so. So it's two triangles. So I'm seeing similarity. I'm seeing that this is R that we are looking for. I'm seeing 18 over here. And I see that this is H over here. And this whole distance from here is 30. So it's like two triangles. So there's similarity. So I will do similarity. I will put R over 18, doesn't matter which one you put over which one, equals 2. So I'm taking the small over the big value, and then I will do the same. The H over the big value. Again, as I said, doesn't matter. Why am I doing that? I'm trying to find R in terms of H. To find R alone here, you take that H over 30, you multiply it by 18. Okay? So I'm just going to write that down here so that you can see. That means that R is going to be 18 over 30H, which simplifies to 18 over 30, that is 3 over 5. It's 3 over 5H. Now I have my R. Okay? I have my R. Now, this, maybe I'll just write it nicely here. So R is equal to 3 over 5H. Good. There they give me the volume of a cone. So just write it down as it is for now. The volume of a cone, they give it to you, okay, is 1/3 of pi r squared times h. Right. What is our r? We're going to substitute where we have r, we're going to substitute that value there. So the volume, because we need to prove this, right? That's what we need to prove. It's going to be 1/3 pi, and our r is now 3 over 5h, but be very careful, it must be squared, times h. So let's just square what we need to square in that bracket. It's 1 over 3 pi. Squaring this is 9. Squaring that is 25. Squaring h is h squared. Then we multiply that by h. Right. Numerators times numerators across the board. I'm going to have pi 9h cubed, so it's 9h cubed pi. That's numerators, numerators, numerators. And then denominator will be 3 times 25. That is 75, is it? No, 3 times that is 75. In fact, before I multiply numerators, numerators across the board, I can see, like to work things, make them a little bit easy, that 3 goes in itself once, and 3 goes there. Now numerator, 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 that is 3h cubed, 3h cubed, h squared times h, pi, all over 25. 25. This is volume, right? This is volume. Did we prove it? Yes, indeed we did. 3 pi h cubed over 25. Doesn't matter where you put out pi. Okay? Still the same thing. Right. So we are done with that. Now they say, very important. So I'm going to bring that volume down. Okay. So let's just bring that formula. I'm just going to grab the formula from, take a snapshot of the formula. Right. So even if you couldn't prove this, at least you have given this, right? So you should say, for example, lose 2 marks because you couldn't prove that for some reason. You can't be losing 4 marks for you to answer the question of part B, right? So what does part B entails? Okay, let's see. It says the water flows in the container at a rate. Now, the rate in which the water flows, if you see, this is 36 cubic centimeters per second. This is volume time. This is the volume dV dt. dV dt, the volume with respect to time, and we know that it's 36. Can leave out the units. Okay. What else? Just before you can understand, then you will definitely have a concept of chain rule. Here, if they say find the rate of change of H, okay, dV dH is what I must find. And when I find this, I'm going to find this where H, then they give me where H is equal to 15. Are we good? Right. That's what we need to find. Right. But from the chain rule, because you need to understand something very interesting. dV dH, the original formula that we have there, should equal to this dV is always on top and dH will be under. Then you are going to put dt here and dt there. Right? So we will definitely have to deal with a few things. Do we know dV dt? Yes, we know dV dt. Do we have dt dH? We don't have dt dH. Do we have dV dH? Yes, we have dV dH. What is dV dH? Well, we can actually calculate it. Okay, so let's find dV dH from here. dV dH, that means if you were now to, remember, if you were now to differentiate that, right, this 3 over 25 is just one number and the same as pi. So 3 pi over 25, they obviously they will be affected because this 3 comes in front. So if I write 3 pi over 25, they will be multiplied by 3, then we reduced 1 at the power. So dV dH, this answer is 9 pi h square over 25. But we'll need a value of h. We know that they are saying when h is equal to 15, then 9 pi times 15 square upon 25, then this is going to be equal to, well, what is it going to be now? We can see that. So let us see what it's going to be. So let's take that. 15 squares, 225, 225 times 9. Okay, that's 2025. 2025 pi divided by 25. Right, let's just divide that answer by 25 to see what I have. Okay, I have 81. This is 81 pi. Okay, why is that 81 pi necessary? Now, I have dV dH. So I'm just going to grab this formula here so you can see what is it that I'm doing. I'm just going to punch it in here. Let's just write down the stuff that I have. Okay, I have dV dH, which is 81 pi. So I'm going to write 81 pi. dV dH is 81 pi. Right. Do we have dv dt? We don't have dv. We have dv dt. dv dt, that's the rate with respect to time, or the volume with respect to time, is 36. That is 36. No units, please. Don't write any units. Multiply. Do we have dt dh? No. We are supposed to calculate dt dh. They're asking, find the rate of h. Find in terms of pi the rate of change of h. That is what we are looking for, the rate of change of h. So we need to find from the diagram we have over here, we need to find dt dh, and it's so easy. You just take 31 pi, divide that by 36. So dt dh is 81 pi divided by 36. We need to leave our answer in terms of pi, so I'm not going to put pi in my calculator here. Or let's see if it gives me 81 pi, and if I put that over 36, might probably give me 9 over 4 pi. Okay, now this is very important, 9 pi over 4. But we are not looking for the rate of change over the time with respect to the height. It's very important that we understand that. We are looking for the rate of change of the height, all right? So we are looking for the h dt. That's what we are looking for. So the h dt is going to be, switch this around, which is 4 over 9 pi. All right. I might have used a very different strategy to explain it to you, but at the end of the day, this is what is required in our answer. You can also leave it in centimeters per second, because it's the distance with respect to time, okay? And that is what we are looking for in this particular case. The rate of change of the distance with respect to time. Everything is always with respect to time, okay? Right, that brings me to question 13. The function is defined for x is greater than equal than 0, obviously, otherwise it would be undefined. But you are now given the derivative. You need to find the equation of the curve by doing antiderivative, that is integration. But before, let me just write it in this form, that is 4x plus 6x to negative 2. Now I can actually integrate that without having too much of a problem. When I integrate indefinite integrals, I have to consider that I am going to have to deal with a constant of integration, and that constant of integration is going to be replaced, since I have a value of p. The x and y value of p's I'm going to substitute in there. So let's first integrate. You know that you add 1 to the power and divide by the new power, so 4x squared, and then you divide by 2. Then it's going to be minus 6x to negative 1. That's why I'm dividing by negative 1. So that's why this becomes negative 6, because it's plus, divide by negative 1. So maybe I'll just leave it for you like this. Then this is going to be plus the constant of integration. So let's just clean this up. What does this become? This becomes y equals to 2x squared minus 6. And I'm going to put that 6 over x. That x looks horrible. Let's just rewrite it. Plus c. What do we now know? In order for me to get rid of that c, I am given a point p. And what is that point p? It's negative 2 comma negative 1. So negative 2 comma negative 1. Substitute for x and for y into the formula. That is negative 1 is equal to 2 in bracket negative 2 squared minus 6 all over negative 2 plus c. This should give us the value of c, right? And if you do so, you will see that this is negative 1 is equal to positive 4 times 2, that is 8. And then you have plus here, 2 into 6, that's 3. That's going to give you c. All of this will say that c will be 8 plus 3 is 11, negative 1 minus 11, that is negative 12. Therefore, our equation we were looking for now is y equals to 2x squared minus 6 over x minus 12. That is the equation. All right. So we have calculated our value, our equation. So integration, if you are given the derivative, then you are looking for the original function, you are integrating. Good. So that brings me to question 14. The diagram shows the curve y equals to the square root of 3x plus 2, positive part, meeting the x-axis at A and the y-axis at B. Write down the coordinates. Right. So if you make the value of y equals to 0, so if I was to take square root of 3x plus 2, if I make that 0, squaring both sides, this is just going to be 3x plus 2 is equal to 0. At the end of the day, x will be negative 2 over 3. Okay, so that negative 2 over 3, that is going to be the place of A. So my A coordinate is negative 2 over 3 comma 0. If I want to find where will this graph cut the y-axis, I must make x 0. So y will be square root of 3 times 0 plus 2. That is going to be y equals to square root of 2. So the value of b then, x is 0 and that is square root of 2. Okay. Then they say find the volume. The region AOB is rotated through 360 degrees about the x-axis. Okay, that's why we had to do that, finding those values, especially the A. Find the volume of the region. Now the formula that to find the volume of revolution is pi, then you integrate from A to B, and then you want to have your function squaring with respect to x. Now the nice thing is the function is already having a square root, but let me just write down anyway. So the volume is going to be from the value of x, the lowest is negative 2 over 3 from what I've calculated, and it's going to go all the way up to 0, where x is 0 here, okay, because we are going to rotate this thing, right? We're going to rotate this thing about the x-axis, all right? So just to emphasize, just take a snapshot of this little part. So what it actually means is that if you were now considering this function, we are going to rotate this whole thing. Can you see it becomes like a ball? And when we are rotating it about the x-axis, that is the volume you are looking for. Okay, anyway. Obviously your x-axis will now protrude from here. So that's the ball we're looking for. Right, what is our function? Our function is the square root, but I'm going to write it anyway, but just remember you don't have to write it because you have the square root of, is it 3x, what is that? 3x plus 2 squaring that with respect to x. So the square root and the square, they cancel each other out. So that's why most probably you will not see it there. Right, so the volume is equal to pi, just writing it again, sorry, from negative 2/3 to 0 of 3x plus 2 dx. And it's now supposed to be quite straightforward for you to integrate that. When we integrate that, I'm going to put my pi outside and add 1 to the power, that's 3x squared upon the new power, plus 2x. And we integrate from negative 2/3 to 0. So you're now going to have to substitute the upper limit. So when we do the upper limit, I'm going to put out my pi. that is going to be 3 times 0 squared over 2 plus 2 times 0, okay, minus, okay, so minus, we're going to put the lower limit, but remember I still have a pi value, so I'm going to have minus pi. In fact, yeah, let's just do that, minus pi, and then I have 3 negative 2 over 3 upon 2 plus 2 times negative 3 over 2, right? Now I'm going to go to the blank page, because what I'm going to get is, I'm going to get the volume is going to be pi times 0, that is what this one is going to give you, minus pi times the stuff inside here is going to give me negative, if I'm not mistaken, it's going to give me negative 3 over 2. No, maybe the other way around. Okay, negative 2 over 3. Right. So just to confirm, take the calculator. I'm really interested in the second part. So I'll be doing the brackets inside the brackets. Okay, I know my negative pi is there. Just to show you the concepts of my bracket here, I've got 3. That's going to be multiplied by negative 2 over by negative 3 over 2. I just have to come and correct this one. It was supposed to be negative 2 over 3. Okay, then all that over 2 plus 2 times, that should be negative 2 over 3, not negative. Okay, scroll back and close that. In fact, let me perhaps also put my minus pi in front so you can see minus. Hopefully the calculator can still do the operation. That's 7 over 3, is it? Okay. Just quickly go back. That's minus 2 times 2 over 3. Okay. Then you have 3. Oh, okay, I left out something. This one was supposed to be squared. Okay. This one was supposed to be squared. So before I hit equal to, let me just correct this. That is squared over here. And this one is supposed to be the other way around, which is negative 2 over 3. Okay. So this lower limit comes in here, right? This upper limit, which is here, obviously comes here everywhere where you have an x. Okay, so in this case I'm going to get 0, and in this case let's see what the calculator gives me. And if you hit equal to 2 over 3 pi, and that answer has to be in units cubed. Okay, therefore the volume is equal to, did they say we must leave your answer in terms of pi? So let's just see. Yes, give your answer in terms of pi. Very important that you always go back, give your answer in terms of pi. So this answer has to then be 2 over 3 pi units cubed. Right, so I hope you had fun, and I hope you have picked up and learned a few things. If you are definitely looking for the PDF, as I'm working this document, I save it as a PDF. I can make it available to you, but these are national papers that you can download, in fact, and I believe that the link is all around the country. Okay, so do get in contact with me if there is more that you need. All right, but then I'll appeal to you to keep on subscribing, because the more you subscribe, the more content I upload. All right, good luck with your studies.